Hello everyone and welcome. In this video we will learn how to compute some indicators for a diagnostic test. Sensitivity, specificity, positive predictive value, negative predictive value. These indicators are in fact percentages or probabilities that measure if the new diagnostic test, can identify correctly a subject as being ill or healthy. So here are the formulas, and we will see that sensitivity can be computed on the first column, specificity can be computed on the second column, and the predictive values will be computed on the rows. Usually, when a new diagnostic test is created on the market, the results of these tests are compared with the best test we have. This is called the gold standard test. So this gold standard test can confirm the presence or absence of the disease and can decide for sure the diagnostic. For example, for tumors, the gold standard test is the pathology result when they see malignant characteristics of the cells at the microscope. Now I will tell you always the results at the gold standard test should be situated on the columns, and the results from the new test should be situated on the rows. So please, all the time in the contingency table, put the gold standard test on the column. Now let's go to our Excel document and build this contingency table. Here we are with our small database where we have a column with the results at the gold standard test and other 3 diagnostic tests to evaluate their performances. So here we have about, let's see, 500 subjects. We will build the contingency table now. To do this, we will need to select the 2 columns where we have gold standard test and the new test to evaluate. So this is the best test we have, and this is the new test we need to compare with the golden standard. We will select the 2 columns with a shift or control, and we will go to the insert menu. There we will find pivot table, and we already have the table range. We selected the 2 columns here. We need our table, our contingency table, in the existing worksheet at this location, let's say. Now this window will appear where we have to decide what we want on the columns and what we will put on the rows. We will select the golden standard test on the columns. It's very important to have this test always on the columns, the test that give us the diagnostic. Then the other test on the rows at the values. You will observe in this contingency table we have some empty row. This empty row is because just below the data we selected are a lot of empty cells. So we need to take these blanks out, this row without values. We will check this small arrow here and we will select blank out. Okay, then now we have only values in our contingency table. As you can observe, we have on the first row and on the first column negative results. Is not good for us. We need to change this table to have always on the first column and on the first row positive results. So we will check on this arrow and select sort from Z to A, and now we will have positive results on the first column, and we will sort on the rows to have positive results on the rows. We are very interested particularly in these 2 values from the cell A and the cell D, and let's see these values better. Here, these 26 subjects are the subjects positive for the golden standard test and also positive for the new test. So, they are true positive. These 348 subjects are negative at the golden standard test and also negative at the new test. So, they are true negative. Now we have these 28 subjects that are negative. They don't have the disease because the golden standard test is negative. But the new test describes them as positive. These 28 subjects are false positive, and these 98 subjects are false negative because they are negative at the new test, but in fact they have the disease because they are positive at the golden standard test, the test that gives us the diagnosis. And as I said, we are very interested in these 26 and 348 subjects that have true results. They have the same results at both tests. These values will help us to compute sensitivity and specificity on the columns, respectively the predictive values on the rows. As we already decided, these four indicators are probabilities. The sensitivity is the probability for an ill subject to have a positive test. The specificity is the probability for a subject that doesn't have the disease to have a negative test. The positive predictive value is the probability for a subject that have a positive test on paper to really have the disease. And the negative predictive value is the probability for a subject that have this negative test to be healthy indeed. So, sensitivity and specificity are about the subject, and predictive values are about the result of the test. Now, let's take another quick look over this formula and then apply them in Excel. Sensitivity will be A, the true positive, divided by A plus C, total of positive subjects. Specificity will be D, true negative subjects, divided by all the negative subjects, D plus B. Positive predictive value will be A, true positive subjects, divided by all the subjects that are positive to the new test. Negative predictive value will be true negative subjects, divided by all the subjects that are negative to the new test. Returning back to our Excel document, we will compute sensitivity. Each formula in Excel starts with an equal. Then we will select 26 and we will divide here. We will divide by the total on the first column and the result is 0.2. The specificity, we will start with an equal. We will divide this 348 by 376 and the result is 92%. The positive predictive value will be 26 divided by 54 and we will have 48% probability. Negative predictive value will be 348 divided by the total on the second row, so 446, and the result is 78%. The only acceptable value here is the value for specificity, is 92%. Well, this proportion, this probability should have values above 80% in order to have acceptable values that can be used in clinical practice. Usually, a test that have a very good sensitivity, it's used for screening. This test can get positive very easy and can take a lot of subjects as false positive. A test that have a good specificity will be positive only if it's very sure about the diagnostic. A specific test is very specific for that disease. So, if the test is unsure about the diagnostic, the result will be negative. Only if the diagnostic is very clear for this specific test, you will be positive. That's why there are rumors, and they said in the lectures, we use sensible tests for screening and specific tests for clear diagnostic. Well, thanks a lot and have a wonderful day. Goodbye.